So why are we concerned about this reactive power? Well, the problem is that even though increased energy input is not required, increased current still flows through the generator windings and through the power system. The result of this is that we could easily overheat the generator windings if we had a high megawatt output plus a high megavar output. Definite limitations are placed upon the combined total output of megawatts and megavars. Megawatts and megavars act with different phase relationships to voltage. Active power is in phase, while reactive power acts 90 degrees out of phase. The combination of megawatts and megavars is known as MVA, that is, megavolt amperes. You will remember that in a DC circuit, if we multiply volts times amps, we get power in watts. However, in an AC circuit, volts times amps, VA, gives us apparent power, as it is a combination of vars and watts. The ratio of true power, that is active power, megawatts, to apparent power, MVA, is known as power factor. This generator capability curve shows us the limitation on MVA due to current in the stator. For example, at this megavar loading, we can only produce this amount of active power to stay within the machine's capability. Clearly, in order to keep within the MVA rating, we must reduce megawatt output if we wish to produce a large output of vars with the generator. However, there are other limits to observe in generator operation. As we know, in order to increase the megavar output of the generator, we must increase excitation. The increase in excitation current flow increases the heating of the rotor winding. This curve shows the limitation due to rotor heating. You can see that we can operate this generator at 180 megawatts and 0 megavars. But if we needed to produce, say, 100 megavars, then we would have to reduce the active power output to 140 megawatts in order to keep within the established rotor heating limits. We also run into trouble if we reduce excitation too much. In this case, as the voltage falls, vars will flow into the generator from the power system. This is shown on this curve as negative vars. The problem is that if the rotor current is reduced too much, the magnetic field may become so weak that the generator will lose stability and fall out of synchronism with the other units on the system. In order to prevent this, a minimum excitation limit is established, which is given by this additional curve here. This combination of limits provides the generator capability curve that you should be familiar with. For each specific generator, this curve is normally displayed in the control room. Make sure that you always operate the generator within these limits, whether you are supplying megawatts and absorbing or supplying megavars. Okay, now that we have you interested in this